Hey guys, thank you all for coming to my talk with the title Python, a language made for test-driven development. We'll talk about how to practice test-driven development in Python world, which libraries to choose, which testing frameworks to choose, how to use them, and why Python is really a good fit for test-driven development. We'll take a look on some of the examples with some live coding, and we'll also discuss how to approach machine learning like solutions with test-driven development, because machine learning solutions are widely implemented in Python. So before we start with our topic, let me introduce myself. So my name is Jan. I'm coming from Slovenia, Europe. I'm tech lead and co-founder at typeless.com. We are developing algorithms for data extraction from documents such as invoices, and we are mainly using Python. I'm also author of blog posts and courses at testdriven.io, and I'm also present on Twitter. I'm working with Python for the last 6 years, and I'm practicing test-driven development, or at least trying to, since the beginning. So let's move to our real topic. So when you're practicing test-driven development, you may face some of the issues, such as a long time to start test suite, writing lots of code for just a simple test case, writing lots of code just to implement a simple thing. You may need to install third-party dependencies just to start writing tests. And when you're in Python world, sooner or later, you will hit some machine learning-like solutions, and they may seem untestable at first because of their undeterministic nature, which means that the given input X may not produce the same output through the time. So when using Python, those things can be really minimized, because Python really tries to make things simple, which is great for test-driven development, which is all about small changes and quick feedback loops. And the less code you need to write to implement a simple thing, the better. The faster the test suite runs, the better. It doesn't matter why it's slow, whether because it needs some time to compile, or because you have slow tests. Either way, you want to have it as fast as possible. So let's start at the beginning. Python comes with unit test library that's built in inside its standard library, so you don't need to install anything to start writing your unit tests. It's XUnit implementation in Python. So if you're familiar with JUnit in Java, it may look familiar to you. And it also comes with a rich mock library that can be used to mock the third-party API calls or databases or whatever you need, because Python is dynamically typed, so it's really easy to rely only on the interface, which mocks can easily provide. So to write a simple test for a calculator, you need to create test class, which inherits from unit test.testCase. And to write a test method, you need to prefix its name with test. And then you can use built-in assertions to assert that add method on calculator behaves as expected. So this pattern may be familiar to you from other languages, because, as I said, unit test is XUnit testing framework. You can run the test inside the current directory by running python -m unit test, or you can discover tests inside the specific directory. In that case, you need to use discover. Your Python models containing tests must start with test underscore, but you can override this pattern and use something else if you need to. The tests test can run really fast. So as soon as you hit enter to run the test, you'll see the results. There is no time to compile, so it's really, really fast to see the results. Although it may seem very simple to use and to write tests with unit test, you can go even simpler with PyTest. It's third-party package which needs to be installed with pip or poetry or any other Python package manager. It requires even less boilerplate code, which makes your tests more readable. It uses built-in assert statements, so you don't need to remember all the assertions that comes with unit test, which also makes your tests more readable and easier to remember. It's simpler to setting up and tearing down the test state with its feature system. It uses functional approach, and it also has a wide range of available plugins, which can make your life even easier when dealing with automated testing. So as you can see, the test for the same add method on calculator is even simpler. So you just need a simple function that uses built-in assert statement and assert that output of calculator add equals the expected value. So that's it for a test when using PyTest. So you can run your tests by running PyTest. It comes with a binary, and it will run all the tests inside your current directory, the PyTest ones and the unit test ones. So if you are using PyTest, you can run both tests with a single command, and you can also select this specific folder just by providing command line argument to a PyTest command. Similar as with unit test, the test suite runs really fast here. No compile time needed here as well. So you hit enter and you have the results. Among all the things I already mentioned, it allows you to run failed tests from previous run. It allows you to run tests in parallel. So for that case, you must need to use PyTest XDist plugin. You can create JUnit XML report of your tests, and you can also run doc tests, which are tests. These are actually more of examples how to use your function or method inside the doc strings in Python. So yeah, that's basically it about theory. In the next step, we will move to live coding, where I will show how to practice test-driven development in Python using PyTest, how to do really small steps from simple implementation with a function to more complex one with a class, but easier to test. And so yeah, let's move there and see the things in the real world. Let's say that we are building a community for Python professionals where users can pose their questions or answer them. And if the users misbehave, they are banned from posting for the next 2 weeks. We can model that with creating a new ban each time that user gets banned. And before the user's post is created, we need to check whether the user is banned at the moment. And if the user is banned, the post creation must be rejected, otherwise the new post can be created. So let's start by writing a test for ban repository. So let's say test ban repository. I have an environment with PyTest installed, which I'll be using for running my test. So let's say test save list active bans by user. I can use docstrings to add the given when then notation in order to create the test more readable and to express my intention better for my fellow developers. So let's say given bans and repository, when bans are saved, then active bans for a given user can be retrieved. Okay, so let's say username equals John Doe, expires at is date time dot today plus the ban for 2 weeks, so I need to add 2 weeks here. Okay, and then I can say ban is ban username expires at. So this is my active ban for a given user. So let's say active ban for John Doe. Then I also need repository. So let's say repository ban repository. Okay, and then I add this active ban for John Doe. Then I can add inactive ban for John Doe. So let's say it's still username, but the expires at is datetime dot today minus datetime dot time delta days 1, so it's already expired 1, and I can also add another ban which is for Jane Doe instead of John Doe, and it can be an active ban. So today plus datetime dot time delta for 2 weeks. Let me fix that. Okay, so when this is sorted out, I need to assert that repository dot list active bans by user, and I provide a username equals a list of active bans, so it's active ban for John Doe. Okay, so that's my test. I'm checking that after all the bans available are being saved, I can retrieve only the active ones for a given user by its username. So let's run this test. It fails, of course, because the ban and the ban repository are not defined yet. So let's add them. So let's say ban, and I have ban here. I can just pass it for the moment and import it here, and I can do the same for ban repository. say class ban repository, and I can pass it just to make it importable. Okay, I can rerun my test. So yeah, ban takes no arguments at this point, so let's change that. Let's implement the init method. So this is username and expires at, let's say self.username equals username and self.expires at equals expires at. Okay, I can rerun. Okay, new error. So one step further, ban repository object has no attribute save. Okay, so I need to implement the save for the ban repository. I'll provide ban, and I'll say at this moment self.bans.append ban, and I also need to add init self.bans is empty list. Okay, let's go further. Okay, save is implemented, no errors there, so I can move to list active bans by user. Okay, and I'll provide username, and I'll return the filtered bans. So let's do that. It's ban for ban in self.bans if ban.username is equals username and ban pika expires at is equal or is greater or equal to date time dot today. Okay, I can rerun my test, and it's passing now. Okay, great. So at this point I can just simply leave it like this, but let's improve it and let's add type hints. So the users which will be using my repository will have easier job, because the IDs will be able to suggest them autocomplete, and also to verify that they're using my methods correctly. And so this is ban, let's import it. Okay, I can rerun the test. It's still passing, of course it should. And I can also formalize my repository, and I can say I'll create a formal interface, although as you can see I don't need to do that in Python, but I can. So let's say I ban repository, it inherits from abstract base class, then I add abstract method. So this is save, which has ban, and it's not implemented. And then I have another abstract method, which is list active bans by user, which takes username, of course, and it pass. It's not implemented. I can inherit from here, and the test it will pass. Okay, great. So I can move further, and I can implement the actual use case which will check whether a user is banned or not. So let's add a test. So test user is banned. Okay, let's write it. So test user is banned, no active bans. So I'll add given when then as before. So given user name of user without the user without any active bans, when user is banned is called, then false is returned. Okay, so let's do that, and let's say username is John Doe. Assert user is banned for the given username is false. Okay, I can run my test. Oh, it's simple and it's failing because the user is banned is not defined. So let's define it. Let's add a new Python module and let's say user is banned. And I can implement the function. So it will take username and I'll pass for the moment. So I can import it. Okay, let's rerun. And it will say none is not false. Okay, this is failing because by default the functions in Python are returning none if nothing else is specified. So let's implement that. Let's say return false. Okay, the test is green now. Okay, great, but let's implement it for real. So let's say repository is ban repository. So active bans is repository dot list active bans by username and return length of active bans is greater than 0. Okay, so this is the real implementation. My test is passing and that's great. So I can move to a new test case. So let's say test user is banned active bans. So one more time, given when then. So given username of user with active bans, when user is banned is called, then true is returned. Okay, great, but here here we have a problem because at this point we are initializing the repository here, and because this is in-memory repository, it's empty all the time. So for this test case, we would need a repository with active bans for a user with given username. So At this point, we could use a monkey patch from PyTest and mock the least active bands by user method, but instead we can refactor the user is banned to be a method on a class instead of just simple function, and we can inject the repository, and we will make it much simpler, and we won't need to use any mocks. So let's do that. Let's say we won't import this, but we will say this is now authorizer, so all similar things will go in here. So let's rename the module, so authorizer. Okay, and I'll import authorizer instead of user is banned. I'll put it here and here, and I'll add an empty story here, because here I can use an empty one, and that's perfectly fine. I can rerun the test here. Okay, of course I can't collect because I need to do my work here as well. So I said I need ban repository. I say self.ban repository is ban repository. Okay, and I can move this one to the authorizer. I need to add self here, and then I can use self.ban repository instead of this repository. I can remove this here, I can remove this there, and I can rerun my test. Okay, this one is empty, so it's passing, but let's say username equals John Doe one more time, and let's say assert authorizer ban repository, but I need to add a ban, so let's say repository is like this, and then I repository dot save ban. I need to import it, so it's username and it's datetime dot today plus datetime dot time delta days 14. So this user now has an active ban, and I can say user is banned for username is true. I rerun my test and they're still passing because this implementation actually covers it, but I locked it with this test because otherwise, as you were able to see, I could use just hard-coded false response, and that all the tests would be still passing. So yeah, that's basically it. Okay, I can add the type hints here as well. So this one is IBAN repository. As you can see, you can start really simple with Python. You can just implement the stuff and then add type hints to improve your code. You can easily refactor, and you can also see, as I was already mentioning before, the tests are running real fast, so there is no compile step, which makes the process even faster. And yeah, you can start with a simple function, and then when you see that you need something else, you can just refactor that into a class or into a couple of functions or whatever you need. So one great thing when doing task-driven development with Python is that you really don't need to plan ahead. You can just go with the flow. You can really go. You ain't gonna need it way. So yeah, that's how I do it, and I hope this will help you as well to improve your test-driven development in Python and test-driven development in general. So let's move to the last topic, which is machine learning and test-driven development, because Python and machine learning are really a perfect couple. Okay, so let's move to the Python and machine learning, which are pretty perfect couple. Python is widely used for machine learning applications, as you may know, and there is some idea out there that you cannot apply test-driven development to such solutions because of their undeterministic nature. As I said at the beginning, two consecutive calls with the same input may produce different output. So yeah, it's true when you want to test your machine learning algorithms or models in the same way as you to test a method that calculates discount based on some parameters. But if you take a step back and think about test-driven development and its red-green refactor cycle, you can see a parallel between test-driven development and scientific methods. So in test-driven development, you have a red-green refactor. In scientific method, you have your hypothesis, which needs to be validated, and then at the end you theoretize your hypothesis. So the question here is, what can I measure, or how to approach such things in order to automate the testing of them. So when you are building a machine learning model, or if you're solving something with a genetic algorithm or anything similar, you know when the model or algorithm is production ready, right? Because otherwise you are just creating a random number generator if you don't know that. And you decide, so this model is a good one based on some parameters. So the question is, how I can measure those parameters? There is no one size fits all straightforward answer here, but you can tackle it and you can approach it, because if you're able to write automated tests for your models or solutions, you can easily train, let's say, 1,000 of models in parallel on AWS servers and decide for the best one and just deploy the best one to production. So you can come to a point where you're able to experiment almost unlimitedly. So you can do whatever you want. You can tweak your settings for model. You can tweak your data set. You can do whatever you want, as long as you know how to measure this. So, for example, you can claim your hypothesis that the 95% of predictions on test set must be correct after the training is done. This here is just pseudocode, although it looks like a test written in Python with PyTest. but it's just the idea. So you train with train set, and then you compare the results on test set, and you'll see the results, and you assert that the 95% of all predictions must be correct if you are working with classification. On the other hand, if you're working with regression or something similar, you can use, for example, that the difference between a predicted value and an actual value must never be greater than some relative part of predicted value. Or you can completely change that that assertion to meet your needs. As you know, if you're working with machine learning, you cannot measure only the accuracy, because you may be in overfitting area, you may be in underfitting area, you may have a too complex model, and a bunch of other stuff that can tell you, okay, this model is actually not that good. So in a similar way, you can assert that your model must not be more complex than some threshold. How to measure that? That's another question. It's hard to answer, but I'm sure that you can find it for your particular use cases. You may assert something about the loss function. So, for example, you may want to prevent spikes in loss function, and you say, okay, the derivative of loss function must be lower than some threshold for all the data points in my loss function. And so similar for other stuff, you can also measure the how quality is your data set, is balanced or unbalanced, and all other things that you need to do with your data and your models. So in such cases, you just need to find something that can be applied to something mathematically. So as I said, derivative of loss function, for example, or difference between the model and the actual value must be always lower than some threshold. You have a bunch of different approaches to do that, but the main idea is, when tackling machine learning, instead of asserting that something must be equal, you are going to an area where you assert that that some error or error rate or derivative is less than epsilon or any other threshold. So instead of looking to a point, you're looking to an area. So my solution must be somewhere here. When you're calculating discount, you can claim my solution must be this. You have a point. But when you have a machine learning, you have an area, and you must lock your model in this area. And when the model is inside this area, you can automatically deploy it to production and don't worry about it. So yeah, that's all about Python and test-driven development from me. Here you have some of the resources that will tell you even more about the topics that I cover. So thank you for listening. I hope you've enjoyed it, and I hope we see at some real life event in the future. Bye.